Hello everyone, and we're live. We're going over the Higher Paper Talk Belt, a set of questions that I created for, I would say they were key questions for the higher GCSE paper. And if you had a go previous, you're probably here to check out the answers. But if you're here in the chat, you can ask any questions you wish. Let's get started. So the fraction is the most important thing in the whole of the GCSE. Like them or hate them, you should get used to them, and the only real way to get used to them is to keep using them. I would say a number of people just do not like them, but they're good. Now this is how we deal with them. I put these as core skills, so if you can do these, I'm just going to talk through them and ask any questions you wish, either in chat or in the comment. So 3/7 of 133. The key thing here is that the word of in mathematics means multiply. And you can look at this in a few different ways. 3/7, it can be seen as 3 lots of 1/7. And so you could find 1/7 and then sort of multiply it by 3. But probably the easiest and most important structure to learn here is that numbers multiply the numerator. So this will be 3 times 133 all over 7. And if you do the calculation on top, you get 399. And still over 7. And if you want to divide by 7, there's a number of ways of doing that with or without a calculator. But if you do have a calculator, you'll know it straight away. If you don't, and you need to use methods, you're going to do 399 divided by 7. Bus stop method, some people call this. Long division. 7 into 3 don't go at all. So that 3 wasn't used. We'll just move it as the tens of the next column. 7's into 39. That's 5. Remainder 4. Remainders are like mods. And that's a very interesting area of mathematics to look into. 7 into 49 is 7. So you see we get our 57. Most important thing is the word of means multiply, and the numerator multiplies the whole number. Right, next one. Find the reciprocal. The reciprocal, if you want to complicate it, it's the number that you're going to multiply this one by to give you 1. But that's a bit of a difficult concept. What you really want to think about is flipping it upside down. So let's not overdo this. The reciprocal of a fraction is to flip it upside down. The top is the bottom becomes the top. Find the value of 7 over 4/5. Now this is a bit of a structure. It's a fraction in a fraction, right? And a fraction in a fraction can put you off a bit. But you need to look at this sign, like the major division, as a division. So we're talking 7 divided by, and then this thing here. Now we're going to employ our little friend, the reciprocal here. Hi Chris, nice to have you here. When we are finding the value of this division, we don't want to divide by a fraction, because again, it's a head mess up. So we do employ this crazy brilliant relationship that says whenever you're dividing by something, it's exactly the same as multiplying by its reciprocal. So what's the reciprocal of 4/5? That's 5 over 4. And then we do the same gig as we had earlier. We multiply the numerators just to be explicit. Looks like this. And that's 35 over 4. And pretty much that's the value, but we can look at that as a decimal, and we know that it goes in 8 wholes and 0.75, so 3/4, so, or 8 3/4. So that's the value of this multiplication. First time to join. Hey, Chris, you're also the first person to ever join, so it's good to have you here. If you have any questions, do ask. Evaluate. This is as hard as it gets, students. Like what you've got going on here, I'll draw it large. There's a whole bundle of things, and I'm going to highlight. So firstly is let's not use blue, is a negative. Second is we've got a numerator of 4. And lastly, we have a denominator of 3. There are 3 things happening to 27. We'll have to go through them because essentially you can write this as the multiplication of 3 things. So it's 27 to the power of -1 times 4 times 1/3. And you can take a look and see that this multiplication becomes -4/3 like we have here. It's the same thing. And whenever you have multiplications, you can write it in whatever order you want. So we could have 27 1/3 times 4 times -1. But essentially we're remembering our index laws that all of these multiplications, they become brackets. So it gives us an order in which we're going to do things. So I put the 3rd first, and that suits us, as you've probably seen. The 4 second, and lastly the -1. So this is how I do my indices. There's a quick way of doing it, and we'll talk about it in a second. But I show it bare bones, like by breaking down the structure, by knowing that this number, -4/3, can be written as these 3 multiplications. So we'll do the 27 first. So anything to the 3rd is a cube root. Really worth remembering. The cube root of 27 is 3, because 3 times 3 times 3 is 27. So that's the first nested brackets dealt with. And the next is the 4, because we still have our structure, which is like this. Now 3 to the 4 is not typically well known, but you're doing 3 times 3 times 3 times 3. So if you have enough patience, you can do it by hand, but the calculator will tell you the same. That 3 to the 4 is 81. And finally, what does this mean? Well, this -1 in the index, that means reciprocal. So when you see that, it just means flip it. Well, how do you flip a number? You can flip a fraction. A number can be written as 81 divided by 1. And now it's a fraction. So if we were to flip this, let's see what I can do about that. I think I'll still have space. I'll do it under here. If I was to flip 81 over 1, it would be 1 over 81. And there's your final answer. We've evaluated this. And there's a way of dealing with this. You could see that if you've got a negative, that means that at some point you're going to have to find the reciprocal of 27. If you've got a power, a fraction here, and the numerator is more than 1, that's your power, or your index. It's probably a bit more technical. And here on the numerator, the denominator is your root. So you see that we had to cube root 27. We had to raise it as a power of 4 to the power of 4, and we had to find the reciprocal of it. And the order in which we did that was beneficial by making the number smaller first, by cube rooting first. Okay, writing 2.32 as a fraction. Disgusting here. But 2.32 as a decimal can be written as a percentage quite quickly by multiplying by 100. So 2.32 multiplied by 100 equals 232, and we know that that is a percentage straight up. Percentages are easy to turn to fractions because percent means out of 100. So literally we can write the percentage like this as a fraction. Job done. We don't really need to cancel it down, but we can. If we think about what goes into 232 and 100, it's 4. It's probably the best I can think of on top of my head. And that would lead to 58 over 25. And that's about, well, there's nothing else, I don't think. It's about as good as we could do. Which, in fact, is mixed, isn't it? So we could write that as it goes in twice. Remainder 8 out of 25. At 8. Moving on. Just checking for chat. No questions. This is one of the best questions. When I went to university, I came back to teach. I was given this question, and I totally forgot how to do it because it's a method, like it's a thing to remember. You can easily pick this up. So instead, I did it from first principles. I proved it myself. I felt very proud, and therefore it's one of my favorite topics. So 0.2 recurring. That's 0.22222. You get the idea. And we're going to call that something. We're going to call it x. This is where your memory kicks in and you're like, yeah, this is how we do this. This old chestnut. We just call it something. Now the question is, do you multiply it by 10? Do you multiply it by 100? I mean, what's the worst that can happen if you do both? So I always say. Sometimes when it's written out and it's in front of you, like, it's just easier to pick up on. What you're looking for here is a subtraction that's going to get rid of this bit that goes on forever. The 2 that recurs. And I could choose many different ones here, actually. I could do 10x, take away x. That's going to give me 2.2 recurring, take away 0.2 recurring. As you can see, that would leave me with 2. I could do, it's going to be a bit unnecessary, but I could do 100x, take away x, which is going to be the 22.2 recurring, take away the 0.2 recurring. And in this instance, it gives us 22. It doesn't really matter. Why don't we look at both? 10x take away x is 9x, and this is equal to 2. As you can see, it's 2 over 9. If we divide both sides, let's give us some space so we can see. We divide both sides, so that x is now 2 over 9. Now that's a fraction, which is what we wanted. And x is equal to our original number. Okay, so this number that they gave us is x. So therefore we've written it as equivalent. What happens if we chose a different thing? It's not the end of the world at all. 100x take away x would be 99x. And then this would be equal to 22. And we divide everything by 99, we get 22 over 99, which you can appreciate is 2 over 9. So you will always get to the same thing. You shouldn't be afraid to just try something, because sometimes when you write it down, it just really works. So just you see something you didn't before. Okay, no questions on that one. I'm sure you did really well. Right, 4 over 7 is a percentage to 1 dp. So we can put on our calculator, but let's just for fun look at non-calculator methods. So we're going to do 4 divided by 7. So how many times does 7 go into this old number? Now we want it to 1 decimal place, so maybe we want a few. 7 goes into 4, none. So decimal place remains in the same place, and we carry that 4 over. 5, remainder 5. 7, remainder 1. 1, remainder 3, etc. Okay, so we've got 5, 7, 1, 4. That's all we wanted. This is the division, because that's what you need to realize a fraction can change to a decimal by performing the division, which is 0.5714. A decimal changes to a percentage by a multiplication of 100. So this is 57.14%. But we wanted it to one decimal place. So 57.1. The 4 needs to be 5 in order to go up. And that is the end of that question. Il n'y a pas de question. Okay, next one. This is going to be the next page. Express 208 as a product of prime factors. Oh, this one I need to tell you about this. I have the Casio FX991 EX calculator, and there's a button. Like, I guess it's really lazy to use it, but I'm quite obsessed with it. It looks like this, because, you know, we always draw that tree, and this can really help you when you don't want to draw a tree. Just know what you're doing with it. Anyway, this button here, if you press shift, actually that's going to be a circle and looks like this. It's actually uppercase. And then that, it will automatically give you the prime factors of a number. It's brilliant, because prime factors are actually really good, really boss. So 208, you type that on the calculator, 208 equals, you have to press equals first for some reason, and then you just shift and press that special button, and you get that that's 2 to the 4 times 13. Now, if you don't have this fancy calculator, which is allowed in the GCSE, then you can just do it the old-fashioned way and do the product of prime tree, where we go through and write it as things multiplying to get 208, but we underline any prime numbers. Now, according to the GCSE definition of a prime number, we have 2, 3, 5, 7, etc. to look out for. So we underline when we get one of those. 2 multiplied by 104. Now we need to keep going. 2 multiplied by 52. We need to keep going. 2 multiplied by 26. And finally, all prime. Okay, so there's your prime numbers. You should know them up to maybe 30. And then what we're doing is seeing that 208, if we took this, multiplied it by this, and multiplied it by this, this, and this, we would get 208. So let's write it like that, just so we can see. This here is the product. Product means multiply of the prime factors. And if we write it in index form, it's a lot easier than 2 times 2 times 2 times 2. All right? So there you go. Final answer. Is 103,680 a square number? This is the best use of prime numbers at the early stages, because of this idea of these primal factors, these prime factors that you can break numbers into. You can see whether they are written as pairs. What a square number is, it's the same number multiplying itself, right? So 3 times 3 equals 9. And we can look at a more complicated one, for example, like 81, which is 9 times 9. But remember that 9 is 3 times 3 times 3 times 3. And if you're going to need two numbers that are the same multiplied together, well, there's one and there's another. You'll see that they are in pairs, right? It's the same number twice. So let's look for that with this. This is one of the best ways to help define a square number. Now I'm going to use my special button on the calculator to show you. Obviously you can go through this whole tree method again, but with the button I can see that 103,680 is equal to 2 to the 8 multiplied by 3 to the 4 multiplied by 5. And we need to know whether this is a square number. It's a square number if you can see two numbers multiplied together that are the same. Now, using the prime factors, I can see that there's 2 to the 4. Okay, because this 2 to the 8 can be split to be 2 to the 4 times 2 to the 4. So we've got a halving there. One can go in each bracket. The 3 to the 4 is good too, because that's 3 squared times 3 squared. So we can put a 3 squared in both. Currently, we do have a square number, because we have one number here and the same number here multiplying together. But this is not 103,680 because there's this 5. If we put the 5 in, it's going to make it odd. We needed 5 squared, right? So we could put 5 in each bracket. But currently, this is not a square number. Okay, let's have a wee scroll down. 0.2 is a fraction. Won't that be 2 out of 10? Yes. Let's go back and show. You're right, absolutely. So if it's, I love my anomalies. If that's 0.2, then absolutely that's 2 over 10. But this is 0.2 with a dot above. And when there's a dot above, that means that the 2 goes on forever. 2, 2, 2, 2, 2, 2. Like, have to stop writing at some point. And this is quite a bit bigger than 0.2. So if there's 0.2 there, let's say that's the line for 0.2. 0.22 is like there. 0.22 is like that. 0.222 is like that. 0.2222, you get the idea. So you're always adding a little bit more. There's probably a limit to that. But it's bigger than 0.2. So we have to deal with it using this special algebra method where we say it's equal to x, times it by 10, and then we do a little takeaway to find x in terms of a fraction. So hopefully that, I don't know if there's a delay to the questions, but hopefully that helps your question, Chris. Okay, simplify 384, root 384. Not one of those ones we typically have in the radar, but guess what? Prime factors can really help here. So we're looking for 384 written as a product of prime factors. But you probably didn't expect me to be so happy about prime numbers, did you? But trust me, they're really good. So if I think about this, I'm looking for, to simplify a surd. Essentially, I'm looking for 384 to be written as a factor of something that can be square rooted nicely. And what can square root nicely? It's very simple to show. Does 16 square root nicely? Yeah, it's 4. Does 15 square root nicely? No. Square root of 15 is, if I want to be precise, 3.87298, and it actually goes on forever. It's just an irrational number. The only numbers that are going to square nicely here, square root nicely here, are squares. That's the opposite of square root. So the square numbers are 1, 4, 9, 16, 25, 36, 49, etc. Okay, so we're looking for those numbers. And remember, we looked at the prime factors here that we think about in pairs, and we can find the square. So I'm going to say that this is 2 to the 3 times 2 to the 3 times 2 times 3. These are the odd ones that can't split, but this here is clearly a square number. So it's 8 times 8 times 6. Oh, let me get rid of that. So there's the 2 times 3 becoming 6. And 8 times 8 is 64. So I found my square number. So 384 can be written as 64 times 6, which in surd laws means we can write it like this. It's two separate surds. And I write the 64 in front because that one becomes really nice. The square root of 64 is 8. And that's done. We've simplified it because we've made the number under the surd the smallest possible. Awesome. Okay, so surds are definitely a skill to be used in the higher paper. So if you want a funny number to be involved in the question to work with, it'll be a surd. If you've got an equation to solve, it's probably going to be a quadratic. That's just how the higher paper works. And to really know, to really understand what these squares are doing and these square roots comes from the problem solving questions, not can you do this, can you do that. There's a lot more to it. What I'm showing you here is some reasoning so that if you're stuck, you can figure it out even if you haven't been shown this exact question before. Like this is what I would go through with my reasoning and get to the final answer with confidence that I took every step correctly and therefore my probability got to the right answer at the end, and that's confidence. Anyway, let's carry on. Simplify. You can see this is a surd again because it's got square roots and they're not too nice. You can't add two irrational numbers together. If this number goes on forever with no pattern, just imagine that, no pattern. You can't say it's 0.2. It goes on forever and it changes, doesn't fit nicely. It's like a Lego block that's wonky. Yeah, it was built wrong at the factory. And it doesn't fit together with this root 33. That's another number that goes on forever without any pattern. So how are you going to add them together if they don't have any pattern? Like, it's not like you're doing 0.1 plus 0.2. Oh, these line up, the 0.1 and the 0.2, so that becomes 0.3. In fact, you may be able to add a few of them up, but the number goes on forever, so you're never finding the exact answer. And in this case, it's best to treat these as algebra in a way, but you'll see. The first things first is to use our previous skill, which is to simplify these. So if we look at 176 and simplify it, we're looking for a square number as a factor. Now the square number as a factor here is going to be 16, because I just sort of figured by writing it as a product of its prime that we have two. What do we have here? So 176 as a product of prime is 2 to the 4 times 11. And so that's going to be 2 squared times 2 squared times 11. There's our square number, shown to be square because it's two numbers multiplied together. And that's 16. Now let's deal with the 33. It's probably going to be something to do with root 11. And you'll see this happen a lot. It's because we're going to be adding a certain number of the root. But yes, because we have a root 11 here, we're going to be looking for that over here. So this is going to become root 3 times root 11. And we're going to have a certain amount of root 11 now. Obviously, it's not the perfect number, but we're just going to deal with it. If we know the rules, we're going to deal with it and know what we're not allowed to do. what we can now do is simplify the front here. The only way to add these two together now, to make it a little bit more simplified, would be to see it as the summation of a certain amount of root 11. So I'm just going to highlight the root 11 there. So we're going to have 4 plus root 3. That's the amount of root 11 that we have. You might say that there's nothing really in common there, so you can't add them as much when you begun, but if you simplify it, you can see we have a number of root 11, and that makes it a little bit clearer for us. Okay, let's carry on. So evaluate. All this is testing is whether you can do these in the right order. So I wonder how you did it. Sometimes we get the craziest ideas. If we just take a step back, act a little bit sensible, always do brackets first. I think, let me give you a tip. Take the time to do each of these rows in turn, because I think people get lazy. I don't think they like to write it out again just for changing one thing. But I do, and I feel like that's really done me good. Second, keep the same structure. This here is a fraction and you're adding 5. You need to keep that same structure. All right? Let me get rid of that underlining. Now we're going to deal with indices. So in fact, root 9 is an index. Okay, it's classed as to the power half. You kind of need to know that for the GCSE. So this is an index as well. So we're going to be doing that. Up on the top here, anything squared is a positive. So we've got a negative, positive 4. Yeah. And square root of 9 is 3. That's still going to be add 5 at the end. Now we've got something a bit more easy. So we've got negative 4 over 5 take away 3, which is negative 2. So we're doing the numerator and the denominator separately. It's not negative 2, it's actually just 2 because 5 is bigger. Always double check. And we still don't add 5. That's at the end. We're adding it to something. Negative 4 divided by 2 is negative 2, and then we plus 5 because there's only addition and subtraction. And we end up with 3. But there's so many different answers there. It depends on which order you do it in. But that's the correct order. There are some ambiguous situations, I suppose, in such cases where you can't really decide which one to go first because they're the same sort of precedent. Then you go from left to right. All right, so there's our basic number skills, and really when they're missing, a lot else has trouble. So hopefully that's helped you, and as you can see, I wrote what the topics were as we went along. As you can see, and you got it here at the top. Fraction of amount, reciprocal, indices, all of these things I would say are like fundamental. And you'll notice out of all the 150 odd topics, I only picked 30 or so because I feel like the rest are, you'll be fine to pick up. But these are underlying fundamental concepts. All right, compound interest, decimal multipliers as embedded notation. What I mean by that is when you're finding percentages and percentage change, that you're going to be using decimal multipliers as like just your standard routine. They're really, really important. Let's get going. What decimal multiplier would decrease a number by 22%? So the way I look at percentage change is not, oh, let's find 22% and take it off. I look at it as, what do I want? You see what I mean? So what decimal multiplier would decrease a number by 22%? So let's say the original number is 100%. And we want to decrease it by 22%. Okay, this is the original route that most people take. They find this and then they take it away from the original amount. But what I'm interested in is finding a certain percentage, like what is the final overall result I'm looking for. If I took away 22% from 100%, that would leave me with 78% of the original number. And this is the number that I focus on with decimal multipliers. If I want to find, this is really crucial, I'm going to write this down. If I want to find a percentage of a number, just multiply by that percentage. So I want to find 78% because that is what's left after taking off 22%. So I just multiply by 78%. Whatever the number is, I would multiply, but sadly 78% is a bit tricky to deal with. It's easier to write it as a decimal, 0.78. And that is the multiplier. Like if you were to do it this original way, if you were to do it this way where you find 22% and take it off, that 22% is different for every question you're ever going to do. And then you take it away. So you've done a unique question and then a separate operation to find your answer. If you do it this decimal multiplier way, then this is the same thing every single time. Like this number, well actually just use this one down here. 0.78 is what you'd multiply any number in the world by to give you a decrease of 22%. Right, I made my point, I think. What decimal multiplier would increase a number by 0.1%? Oh, this is where you doubt yourself because you don't often deal with such intricacies, right? So in this case, we're going to be using the same like logical structure as we did here. We're going to say 100%. We're going to increase it by 0.1%. And that's pretty clear to see that we're going to get 100.1%. This is what we want. Okay, we want 100.1%. And if we want 100.1%, just multiply by 100.1% in decimal form. How do we get decimal form? We divide by 100. It's pretty straightforward to see that if this is going to be divided by 100, it's going to get smaller. Decimal place moves 1, 2 this way. So we get a decimal multiplier of 1.001. Beautiful. Something so technical. This is our decimal multiplier. Something so technical can be structured, and we didn't even use too many brain cells, right? Okay, so next one. In a month, your investment grows by 15%. So whatever our investment is, we don't know, we'll call it X. It grows by 15, no, let's not call it X, it looks like a multiplier. Y grows by 15%. We should know that if it grows by 15%, the decimal multiplier is 1.15. Why? 100% plus 15% equals 115%. That is an increase of 15%. 115% is 1.15 as a decimal. So that's what happens in the in the first month. And in the next month, it goes down 15%. So how do we take off 15%? Well, let's have a look. 100% take away 15%, because the new 100% is what happened, you know, it's more than before. So that's where the trick is. But hey, 100% take away 15% equals 85%. And 85% is 0.85 as a decimal. So that's the decimal multiplier. So these two things are happening. And what we want to know is overall what has happened to y. So we can look at these two Let me write that properly. We can look at these two numbers and see what they are overall. So 1.15 times 0.85 is, and I'll write this down, 9775. Okay, now we can think about what effect that has by reversing our previous logic. Now, if this is the decimal multiplier here, 0.9775, we can work backwards to find it as a percentage. So we times it by 100. So that's 97.75%. So what's the overall effect if we end up with 97.75%? We could do 100, take away the 97.75 to give us the percentage that we sort of took off, and it's 2.25%. So overall, this represents a decrease of 2.25%, which goes against intuition. If something goes up 15% and then it goes down 15%, we naturally assume that's an addition and that's subtraction, and we end up where we've started. Unfortunately, with percentages, if you find a percentage of a bigger number, it's bigger. So A. Let's go to the next question. Check 4 questions. No problem, Chris. It might be the worksheet. It might be that it's so small it was hard to see. So always look for the detail, I guess. Your $15,000 car depreciates. That goes down. That's what it means. 1.5% every month. How much is it worth in 3 years? So this is our standard compound interest question. Has to be here because you have to understand this principle. It could be going up, it could be going down. What's difficult about this question? In fact, it's depreciation and it's the small percentage. These are 2 things, but apart from that, we'll be okay. Let's generalize it like so. We could take our original amount, and if it goes down by this amount each year, what is that as a decimal multiplier? 100 take away 1.5 is 98.5. So we're looking for 98.5%. And as a decimal, therefore, that is 0.985. Now, if you can go straight to that in your head, well done, that's great. But use this structure, this little takeaway, to find that if you can't. That's every single month. So 0.985 for the first month. Whatever that is, we're going to multiply it again. And then whatever it is, we're going to multiply it again. Essentially, we're going to multiply it by however many times. Like 0.985 to the power of 3. And this is your standard setup. This is the original amount. I don't know if I should generalize this too much. Let's call it O, multiplied by the decimal multiplier that's going to represent the change in percentage to the number of years. Like this is a standard setup for this type of question. And now we just have to put that in a calculator. So that's 15,000 multiplied by, open bracket, 0.985 to the power 3. Now you might have to use the calculate button that looks like this, because squared is the button, but maybe cubed isn't. Anywho, what have we got? 14,335. Do you know something about this car? We have to write in dollars, and it's 07 because you do it to 2 decimal places for money. You know something about this car? Something special about it. After 3 years and it's still above 14,000, must be a special car. I don't know, maybe it's an ex-celebrity car or something. But that's definitely unrealistic expectations for owning a car, guys. All right, simplifying and working with algebra. We've got to hit it sometime. So, simplifying and working the algebra. Let's collect like terms. You would do whatever you can. I used to love making up different symbols for this. So, underline the x's. We've got some y's. That's a squiggly line, by the way, not a W. And we're going to just collect them together if they're in the same family. So there's 3x plus 11x, that's 14x. We've got 5y, take away 13y. So overall we're minus 8. And then finally minus 3m squared. You can get creative. That's as much as you can do. You can't add or take away terms that are not like terms. Okay, simplify this. How do you simplify something? You can figure out like what it is. Simplifying means that what it doesn't mean is you've got A's in different places. That's ideally what it doesn't mean, right? So I'm thinking we're going to collect some terms together and see how this goes. And if you're stuck, like, maybe there's a couple of lessons here, but if you're stuck, you just have to try something. I'm going to say that 100 times, aren't I? So if you've got a bracket with a index on the outside, this cube applies to all three terms in the inside as long as they're being multiplied together. So this is going to be 3 cubed, which is 27, a cubed, b cubed, take away 20, b cubed, a cubed. Well, forgive me, I'm going to be writing it like this. Because they're all being multiplied together, actually makes it a lot easier to see that these two are like terms. You have 27 a cubed, b cubed, take away 20 a cubed, b cubed, which is 7 a cubed, b cubed. A cubed, b cubed is a thing. It's called a cubed, b cubed. Factorize. Factorize means you're going to write this as a product, as two things multiplied together. Easiest way to do this is to look at common factors of both. The most primitive, or should we say, first principle way of doing this is to write prime factors. So let's do it for once. 24 can be written as prime factors as 2 times 2 times, so that's 4 times 6, so that's 2 times 3. Times, we've got x times an x from the x squared, times y times y times y times y times y. Let's write it all out, he says. Oh, yeah, big numbers. 1, 2, 3, 4, 5. Good. Take away. It'll only take a minute. 2 times 3 times 3. That's going to be 18 is prime factors times an x times y times y times y times y times y. I'm doing this if you've never seen it before. This is this is y. It's not a joke, but this is like how it works. Okay, you need to know. You could either see what goes into both. So what does go into both? I can only see 1, 2. I can only see a single 2 in the right, so I can only say that a single 2 matches it on the other side. I can see a single 3 on the left, so I can only take one of those 3s and pair it up with the one on the right. What else we got? There's a single x on the right, so we can only take one x from the left. Always a hard bargain, isn't it? Gosh, what colour? I'm missing a fundamental colour here. Alright, let's go for blue. Let's see if it works. And we have got 1, 2, 3, 5 y's in the right as well as 5 y's in the left. So these are the things that go into both. So we can write that out the front. We can say that if it goes into both, then it can be distributed across both with a distributive law. And that factor would look something like this. So that's a 2 times 3 times x times y times 1. In fact, let's simplify it because it's getting crazy. 2 times 3 is 6, x and y 5. Now you probably did that in your head to begin with, but I was, as I said, showing you, if you can't see it in the exam, you're going to refer to this structure method. That's the first thing, right? So that's the one factor. And what would you multiply that by? Well, it's going to be distributed across 2 terms that you took out of. It's essential to see this as a division. Because when you take this out, you're doing the opposite of what you intend to do with it. Write it as a factor. You're dividing it out. So how do we know what goes in this bracket as the second factor here? Well, it's going to be if we divided each of these terms by what we took out. So the first one is 24x squared y to the 5 divided by what we took out, which was 6xy to the 5. 24 divided by 6 is 4. And x squared divided by x is x. And y to the 5 divided by y to the 5 is 1. So 4x. And the next one, 18xy5 divided by what we took out, 6xy5. That leaves us with 18 divided by 6, which is 3. X over x is 1. Y over y5 is 1 as well. So it's just 3. In fact, let's make it a bit smaller because no need for it to be so big. There you go, factorized. That was a long way of doing it, but I think you're here for the answers, if nothing else. And if you're not here for just the answers, well, you're going to probably want to look at this and see how it really works underneath the hood. SG, times and x looks similar. It's true. It does. That's why we have x in algebra as the 2 C's, and times has the straight lines. Even then it goes wrong. So always use a different letter if at all possible. True story. Okay. Let's have a looky. Simplify. What do you mean simplify? It means get, like there's a b here and there's a b here. We just want to see one b. I think that's what we're looking at. Okay, so according to that rule in the last question, this can be written as a cubed, b cubed. Okay, it distributes across both of those. Times b cubed. Now, all of these are in fact being multiplied. So it's a cubed times b cubed times b cubed. And you should know with your index laws, if you're multiplying two numbers together, most importantly, that they have the same base. Here, the base is b, that you add indices. So this becomes a to the 3 multiplied by b to the 3 plus 3. I write it out like that because it reinforces my memory of how this works. You could do it too. That becomes b to the 6. There you go. You've simplified it because now there's only one a and one b. Expand is the opposite of the factorizing. So you're going to distribute the 6 across the 2x and the 9. Okay, so I'm going to be a rebel and go underneath. No one does that. 6 times 2x is 12x, and 6 times 9 is 54. You'll probably doubt yourself in the exam and things like that. Just nerves. But you've got to try and believe in that first answer that comes in your brain because it's often correct. And then you get in the flow of confidence. Okay, so I've done it. But I want to introduce some method here that I find helps. Every time you multiply two things together, you're essentially finding an area. So you can write this as an area where you have 6 as a width here, and the length is the addition of these two parts here. So 2x and 9. If you did 2x plus 9, that's the entire length. So to find the area of this, we'd multiply individual parts together, which is 12x and 54, and the total area would be 12x plus 54. Box method is super good for multiplying and keeping things compartmentalized and organized. It's really neat. All right, expand and simplify. Same method, but we need to keep structure, okay? So we're going to be doing this, take away this, and that's how I'm going to see it in my head. So first call is this, so 10, 5 times 2, and then x times x. Next, 5x times 3, which is 15x. It's a positive because they're both positive numbers. That's an expansion of the first one. There's a takeaway that is separating these two. That's one way of looking at it. The other way of looking at it is there's an addition separating these two. And there's a bit of a mess up in your head, but I'll show you what I mean. 2x plus 3. We could say it's adding negative 3x minus 4 minus 2x. So I can turn any subtraction into an addition. So there's two ways of looking at this, and I'll be honest with you, I look at it this way, where I'm multiplying in a negative, because there's only one time I deal with the negatives. But to keep like pure structure and simplified, we could say that there are two terms being added here together, if you wanted. Let's keep the way I do it, and I just say this whole thing is going to multiply in twice. It's a negative, right? So negative 3 times, negative 3x times negative 4. So we're going to get positive 12x. Because two negatives make a positive. And then we've got negative 3x times negative, so that's two negatives again. We're going to make that positive 6x squared. Essentially, there's an addition in here, isn't there? It's like that. But doesn't need to have brackets. All right. Anyway, that was when you really think about these, like why we do them. Sometimes they're just habits, but to really go into detail, it's interesting. You want to question everything you do, really. So that's how you understand stuff. Expand and simplify. Well, have we simplified? You might be surprised to think that this is not simplified. You might think that it is because you've expanded it, but truly simplified expressions are factorized. So where they currently are in two separate places, not the best, but now we've expanded, we've combined with addition, and if we factorize again, we actually get the proper form for the simplification. Now 16 and 27, on top of my head I can't see any common factors. If you can, just shout out in the chat. But I think that's a no, and don't say 1 because you know how that gets you. 2, 4, yeah, so I'm just going to say the only thing common here is an x. If I just take that out, this is technically the most simplified. Okay, so when factorized is the most simplified. Fact. All right, expand. This is where we notice a surd, and so maybe you want to use a box method. When I'm in the exam, I don't know. I do it this way. I don't mind. Kind of looks neat as well. So everything has to multiply everything. If you're doing it with arrows, sure, fine. Do whatever method you feel comfortable, or if you want to do it in your head, I can, but if I was in the exam, I'm a little bit risk averse, so I probably wouldn't. I would just make sure that I was aware in the exam I'm not myself. So I might want to just take the extra time and be really careful. Do things one at a time. Anyway, let's double check where we're at. So we've got x root 2, yep. And now we have to add them together. So if we've got any like terms here, not particularly, we've got an x squared. We've got a certain number of x, I suppose. So we could call it, no, let's not do that yet, because that might just confuse. I'm going to put it in brackets, root 2x, take away 3x, minus 3 root 2. Now let's go through what these are. This is totally a variable, right? It's a letter squared, it's done. These are two terms, there are a certain number of x's. We can complete this together. We can sort of say that it's root 2, in fact, should we call it minus 3 plus root 2 lots of x? Because if we wanted to know how many x's we have there, it would be a matter of summing their coefficients. Like, I'll give you an example. If it was 3x plus 2x, what are you doing to find out how many x's there are? You're doing 3 plus 2 and putting an x at the end. And that's what I'm going to do here. I'm going to say positive root 2, negative 3. I have to write it this way so it's clear. Negative 3 plus root 2, and then I'm going to put an x. And that's really what is it. And at the end, we've got a number. Yeah, 2. And this number, we don't really care for much for it, but this is what it is. So we've expanded the brackets now. This was not necessarily to get the final answer. This is good. If you've only been asked to expand, then what you're doing extra, but this is pretty sharp down here if you do the second one. No more questions. Good job, everyone. Seems to be going down well. Why has he done this, you ask? Well, I've done the triple brackets with horrible numbers because essentially not only do you need to be able to expand triple brackets, you need to be comfortable using decimals, fractions and percentages and all that jazz. So we're going to set a challenge now. We're going to do this with our calculator. But first, the way to deal with brackets that are triple, the 3 of them, is to do 2 first. So we're going to do the first 2 first. So keeping this really as neat as possible, we can have this off to the side. I don't really want to do it in my head if it's important to me. And then don't worry about the negative. It's definitely going to be negative because that's positive. What's 5 times 0.6 is 3. There's a number of strategies of doing this. You can imagine it as 5 times 6, which is 30, but then make it 10 times smaller because you didn't work with 6, you worked with 0.6. So this going to have some terms, which is h squared, and it's going to be negative 5 plus 0.6h. I did try and make this tricky for like decimal usage, but essentially it's going to be negative 4.4 h take away 3. Now this is a bracket. I might just steal that away to here. And this is the first 2. We now have to multiply it by the other one, the third. So this requires a different type of bracket. Now it's a little bigger, but we can deal with it. As you can see, there are 3 terms in this one and 2 terms in this one. That's why we have a 3 by 2. So h squared minus 4.4h minus 3 h and minus 2/5. Now, when the numbers are tricky like this, yeah, the tough numbers that you can't just do in your head like times tables, this is when you know if you know the method. And I encourage you to use odd numbers, especially in real life. Numbers are not nice, like whole numbers. I mean, there's very rarely is anything a whole number. In fact, mostly things are quite irrational. Anyway, moving on. 0.4h squared minus 3h minus 2/5 h squared. And this is a tough one, I guess. How would I do it? So 4.4 multiplied by 2/5 negative. Well, first of all, I know it's going to be a positive. So in fact, they don't need to be there because two negatives are going to be positive. I'd probably write 4.4 as a fraction. When would that be a whole number? Well, I would want this to be out of 5, really, and 5 works for me because if these two are 5, I don't know, that doesn't make a difference, but whatever. So if I times 4.4 by 5, I get 22. And then I can multiply those two together to get 44 over 25. So this is like the result of multiplying those two horrible things. And no one needs to use decimals here. We're just using basic times tables. And you know, it's a pretty nice way of writing things. If you're into it, 4.4 at the top here can be replaced with 22 over 5 as well, couldn't it? Negative 3 times negative 2/5. Well, ignore the negative again. 3 times 2 is 6. And over 5. There you go. So our final answer is where we add all these things together. We've got like terms to consider. So the only h cubed... Oh, did I write squared? Yeah, that's definitely a cubed. The only one is there. For the squared, we've got some here and here. You see the pattern? The h's, and then finally the numbers don't need their own color because you can see them. So we're going to write them and add at the same time. So what is... remember that 4.4 is 22 over 5. So 22 over 5, and there are two negations, so 22 and a further 2 would be minus 24 over 5. Yeah, it's actually really nice to use fractions. In fact, is that right? 4.4, let me write that out. 22.5. And then, yeah, that's right. And then we're going to take away 2, 5. 2 over 5. That's correct. Minus 24 over 5. For some reason, it just didn't look right for a second. But yeah, there you go. And lastly, oh no, not lastly, penultimately, we've got, I guess, a problem here, but we can sort it out. Look at the side. I'm going to do this without a calculator again. 44 over 25, take away 3. Now 3 is like a whole number, but I'd like it to have a common denominator with the 44 over 25. So what divided by 25 is 3? Well, it's 75. So I can write this in a way that we can best understand it. So 44 take away 75 is minus 31. That's going to be squared, by the way. And then we're going to be writing minus 31 over 25h. The easy part, plus 6/5. Okay, so we've expanded this, and there's the final answer. You should note that we have... This is a pretty high order skill, if I remember, in the GCSE. It's quite high up. Just take your time on it. Do 2 first, and then finally the big old one. But look, the have here descending powers of h. This is h to the 1, but we don't need to write 1. And then on the bottom here, we have h to the power of 0. And anything to the power of 0, let's call it y to the power of 0, is 1. So therefore, it just doesn't have to feature at all. But it is in descending order. That's the best way of writing it. Alrighty, let's move on. Tough stuff. In fact, yeah, we can do it up here. Whew, quadratic equations. So there's all sorts of quadratics to do. Let's just get on. By completing the square, find the turning point of the following equation. Ugh. So completing the square where there is a number in front is a bit awkward, so we have to factorize that out first. So x squared, take away 10x. In fact, we could do like the whole thing, but it's not necessary to do it. It's just going to take it out of the first two terms. That's the way I like to do it. You can do it out of the whole if you want. So let's have a look then. The turning point is the point that the completed square form will find for us. We're going to be completing the square with what's inside the brackets here. So it's going to be x, take away half of that, 5. And that's going to be our first estimate. We're going to subtract this term in here squared. So it's always take away. Just take away whatever that is squared, because that's the difference. And that is now a completed square inside the brackets. The next thing is to redistribute the 3 in. So we get 3x minus 5 squared minus 75 plus 63. And the final form is 3x minus 5 squared, where we're looking now negative 75 plus 63 is a difference of 12, right? So take away 12. This is the completed square form, and to read it, we look in the bracket for the x term and the number on the outside for the y coordinate. So the coordinate, the turning point here, is the opposite inside the bracket, and the exact same sign on the outside for the y. So there's the coordinate of the turning point. 3 doesn't affect it. I know a lot of people think it does, but it doesn't. Best to prove with transformations. Right, factorize. If you didn't realize, this is a what is it? Difference of 2 squares. So this is x squared. That's definitely a squared number. And this is 6y all squared. Okay? So it's definitely 2 numbers being squared. The way to deal with this, notice it quickly in the exam that you've got a square number, take away a square number. Square root of x squared is x, goes in the first 2. Square root of 36y squared is 6y. One of them's plus, one of them's take away. It's definitely much quicker than the quadratic methods that you might do elsewise. So do watch out for it. The next one is where we have a negative in front of the x. It's really not something you want to deal with. Get that out the front. Okay, so negative 1 can come out, making the rest of your quadratic positive or negative. It switches the signs. And negative 1 becomes a factor, so you're on your way. Now we need to factorize this thing. So 2 factors 36 that would give you 5. Look at the pairs. 1, 36, 2, 18, 3 and 12, get in there, 4 and 9, there you have it. So negative 1, and we get x. One of them is going to be positive, one's going to be negative. We have to plus 9, take away 4, because I'm thinking to get a 5, it's 9 take away 4. But then positive 9 and negative 4 is still going to give us multiplication, negative 36. That's all good. Really, that's fully factorized if you think about it, because that's negative 1 is a factor on its own. That's a factor. But there is definitely a something about multiplying this negative 1 in. And I would choose to multiply it into the second bracket in this case, because it already has a negative. And therefore my final answer is going to be x plus 9, 4 minus x. What is the effect of multiplying the minus in? It changes the sign of everything in there. So you can see that happened there. Some people don't fully understand why you don't multiply both, but it's like three numbers multiplied together there. You got minus 1 times 3 times 2. And you only need to multiply these two together to see the effect of minus 1. Or you could do those two together. The fact is, multiplication, you could do it in any order. So we choose to do it in the order that helps us best. And I think that's the best bracket to multiply into. Alright, if the area of the following rectangle is 63 centimeters squared, find the value of x. Yes, this is a quadratic. We know the area of the rectangle is 63. And the area is found by multiplying the width by the length. And so we'll do that. X plus 4 to x minus 7. And when multiplied together, it gives us 63. So we have with ourselves here an equation, because we have an equal sign. Okay, that is what allows us, when it says the area is something. To solve it, difficult. We've got two x's. Let's expand the brackets. 2x squared minus 7x plus 8x minus 28 equals 63. It's looking like a quadratic, isn't it? 2x squared minus 7, so plus x, and minus 28 plus 63 is 35. Yeah. What did I do there? Well, I sort of moved over to the one side. In fact, is that correct? No, I take it from both sides, aren't I? Yeah, that's right. So minus 28, and I'm going to take away 63 from both sides, so actually minus 91. Okay, so that's our quadratic. It doesn't look like a very nice quadratic, I'll be fair. But hey, here we go. This quadratic, there's like no x on its own. So you can't just like say x is 10. It requires quadratic methods to solve, and your calculator does this. Okay, so if you go to the menu, equation, polynomial, and then degree 2, and you just type in the coefficients, and you'll get your answer. Now, I will do that for the purposes of this video, but there are a ton of ways of doing this. So the first solution is 6.5. The other solution is -7. Okay, now we're going to have to evaluate which one is correct. All quadratics give you two answers, and one of them will work, one of them doesn't. So let's just have a check, see if one of them makes sense. If it was 6.5 plus 4, that works for the length. And if it was 6.5 times 2, which is 13, take away 7, that works for the width. It's positive. But if it was -7 plus 4, that would be -3 for the length. And so this one doesn't work. And we're going with the positive value. So x equals 6.5 is the value of x. Now, I use the calculator. There are so many different methods for doing quadratics, and you need to find like time to go through them. I do have like a whole video series. We're going to see some of them maybe here. So solve x squared plus 5x plus 4. It looks like a very basic one to me. So I'd probably just do a basic table of factors to say, okay, 1 and 4, 2 and 2. It looks like 1 and 4 are going to get me to 5. So I would do 1 plus 4. So this second column on the left, I'm just adding positive and negative to see which one is, like how would I get to 5? If that was a positive 1 and a positive 4, then I would get to positive 5. So in that regard, these are the two numbers I'm looking for to go into brackets. So x plus 1, x plus 4. Make it super clear for you that whatever these numbers are, that's what goes in the bracket. Straight up. Of course, you have to decide it. You have to see if that actually works, right? So double expand. That's 4x, 1x. Yeah, it does work. In the case here where you've got a 2 and it's all suspiciously even, don't forget to divide everything by 2. So this is x squared plus 10x plus 21. And then this will just be standard methods, hopefully. 21, 10, 3 and 7 we're going to go for. X plus 3, x plus 7. There you go. I did say solve, didn't I? Right? So I'm going to go back and actually solve them, noting that they're equal to 0. So when they're equal to 0, the bracket, remember, if you can get the whole bracket to 0, then you will have found a solution. So what value of x is going to make that left bracket 0? Well, it's going to be -1. And what about for the other bracket? It was -4. Two solutions, don't forget. For this one is -3 and -7. How do we solve this chestnut? Well, we're going to take that negative out. And we can decide, to... I guess you can factorize it out. You can use a calculator, but you're going to get the same solution either way, because you're essentially aiming to get this thing here, right? So let's take that as it is, and go for the negative out. Oh, don't forget you could use a calculator. Did I mention that as well? I guess so. -1 can come out, and we have x squared minus 7x. Where are we at? Minus 30. Okay. And then we factorize these brackets. Don't forget the -1 is out the front. What are we going to do here? So we've got -30, so that's 1, 3 and 10. Why do I go for 3 and 10? So x minus 10, x plus 3, x squared, yeah, minus 10 plus 3, looks good, and then minus 30, okay. And then we've got that negative to contend with, so I guess we can just put that in. So 30, yeah. I guess we'll combine it with this -1 here, whatever. But essentially it doesn't matter what they are. This -1 could come in, but it's having no effect because it's just a number, right? It's just this lonely -1 at the front. So with it being out the way, we can just focus on what makes these brackets 0. And in the first one, it's 10. And the second one, it's -3. Okay, solve this one. This is where, we're using all these quadratic methods. And this is where it'll throw you off and you think, oh, I've got to use the whole quadratic table thing. And actually, it's just a basic one, but it needs to be here so you can see it. Some people try to rearrange it and go x squared equals 6x. Okay, divide both sides by x. Okay, x equals 6. Okay, well that's one solution, but because you divided both sides by x, you've lost out on the other solution. So let's just quickly show you what you should do, which is factorize. X is going into both there, so x minus 6. That's the factorized version. Now, we're looking at the value of x that makes this whole thing 0 because it's equal to 0. What could this be? The x on its own could be 0, right? And then if that was 0, the whole thing's 0. And in the bracket, the x has to be 6. So in fact, there are 2 solutions here. And if you did that whole rearranging thing, you're going to miss out on one of them probably. Okay, this is a really long video, and it's probably about time to, let's say, continue on a different night. Because to me, it's quite late. So I will get to the end of this section, and then let's say adjourn to another night. But it'll be like tomorrow night or something. I'll put it up on the schedule. So solve x squared minus 8. Well, what are you going to do? Going to move the 8 over. Like that. Is that what you would do? And then you'd square root. Now, depending on how you're going to do this, there's 2 possible solutions. Yeah, plus or minus 8. And we have to look at the context as to what you want. If we're going to go into surds here, this can be 2 root 2. And that will be fine for that one. But I would say, depending on the context, a couple of options. Last one, x squared plus 3 over 4x minus 5. We're going to solve this using quadratic methods. So let's see where the journey takes us. Using our basic one, which is factorizing, we'll probably look at 1 and 5, right? And we're trying to get to 3/4. Automatically thinking this is not going to go down very well. 1 and 5 are not going to get to 3/4. So our basic, putting it into like brackets, is not going to go down. It's not going to work. So what other methods do we have? We have the calculator. Okay, well, if you've got one, use it. The third method is probably going to be complete in the square, but it's not ideal when it's a fraction. And so what you're left with is the quadratic formula. So minus b plus or minus the square root b squared minus 4ac all over 2a. And you see, it's not so scary. When you go through what your answers are, your options, there's not that many. So we have negative b plus minus b squared, blah, blah, blah. Great. So what is a and b and c? Well, a is the number in front of the x squared. B is the number in front of the x. And c is the number in front of, well, it's the number at the end. So minus b is going to be minus 3/4 plus or minus the square root of 3/4 squared, subtract 4 times 1 times minus 5 all over 2 times 1. And the thing that gives us 2 solutions is this thing here. So when that is a plus, that's first solution, and when it's a negative, it's the second solution. And what do we get when we put all of that into the equation and work it through? Well, we get, with a positive, is going to be negative 3 plus the square root of 329 all over 8. And we're also going to get negative 3 subtract 329 over 8. Because there's one where it's positive and one where it's negative, right? Question being, what are those as decimals? It might make it a little bit easier. X equals 1.89. And for the second one, x equals 2.64. That's a negative 2.64. I think what I wanted to get through for this question is that when you have quadratics, there are definitely different ways of solving each one. And we've gone through most of the important ones here. And when it comes to this particular one, none of them are going to really work. And the last result is going to be the quadratic formula. That the numbers aren't always nice. I've rounded these. And you have to round them appropriately, but they're not always nice. Bob Michael, plus minus. What's that for? You mean what I highlighted the green, plus minus? The symbol when we write plus minus, it just shows that you have two options. So you kind of need to do the one where it's plus, and the other option is where it's minus. So that's represented by these two here, where the only thing that's changed is this. And that's where we get our two solutions. Is that what you mean? Or is it the previous question? Because it's dependent on context. And yeah, you're right. Plus minus. I think I was going off on one talking about stuff and I didn't end up writing it. But yeah, plus minus. Yeah, good job. Yeah. But it's all about context. Because, yeah, if you draw this graph, okay, so this is x squared, looks like this, and minus 8 looks like this. Technically, the function has two solutions, right? So one where it's, let's go for the root 8 because it's easier to write, plus root 8 and negative root 8. So you got those two. Now, if this solution happened to be a real life situation, like you were trying, wow, look at that, like you were trying to find the side of a shape, then it can't be the negative one. Yeah, but in a pure way, it has two. I guess that's it. It's pretty late. I could probably go on a little bit, maybe to the o'clock. Look how many pages. I've made so many questions. It's good stuff. But it does take time, doesn't it? And that's why revision isn't always a last minute thing. Let's do a few more. The common denominator here, I'm going to call it a squared. Okay, that's what I'm aiming to get. So I'm going to multiply. Let's write it off again. I'm going to multiply this side by a on the top and the bottom. And hopefully you can see that's going to give me something that matches on the denominator. You can only add things if they have matching denominators. So 3a plus 10, holy moly. Let's move that across to the side. Is going to add together, and that's over a squared, which is our common denominator. Why did I do that? This one was here because most people try and change both fractions, and in this case it was only necessary to change one, so be aware that you can save a bit of time. Traumatized by plus minus. Yeah. It's only really like one of those things that it's a notation. It's lazy, right? So we don't want to write that there's like going down two solutions. We just write it as one because it's neat. But yeah, it's a pain. You know, when it comes to it though, split the page. Like I should probably write it like this. Yeah, we've split the page like you've gone in two directions, and work on one and then work on the other. Let's scroll down. So evaluate x over 3 plus x over 4. Again, you want a common denominator here. The common denominator is 12. So we're going to do a multiply by 4 on this side and a multiply by 3 on this side. Just because it's algebra doesn't mean we're going to do anything different. So 12. We did the same to the top and the bottom. That's essentially the principle here, right? Same with numbers. And now we have a common denominator. It's going to be the numerators added together. So it's not that wild. It's both in terms of x. So 4x plus 3x is 7x. And you could go on and cancel the 7/12 if it cancelled, but in this case it doesn't. And that's all you need. This is technically also can be written like this. If you've never seen that before, you can write it like that, because any number is going to multiply the numerator. Depends if you want to write it like a fraction multiplied by x, or you want it to be 7x over 12. But yeah, pro tip. Evaluate just means like work it through. So we're going to work it through. If we got multiplying fractions, sometimes there's some cancelling to be done beforehand, but this is just testing, do we know how to multiply three fractions together when they're not numbers to comfort us? And essentially, you could do 2 at a time, or you could just realize that all of these are going to be multiplied together. So we're going to get 4xf squared. In fact, let's do it in alphabetical order. S squared x all over 7ab. Not too bad. Simplify. Okay, common denominator again. Like, I know it's horrible on top, but common denominator here is going to be 10, because 2 times 5 is 10. That's the way to go. So stick with the method, all right? It might be more complicated, but if you stick with the method, it's going to be fine. Have to do the same to the top and the bottom. Okay. In fact, hold on. This is multiply. Nice. Does that change anything? Probably. By actually multiplying the top and the bottom there, that's going to make life a little bit more difficult, because we're introducing more factors. Simplify this just means, by the looks of it, multiplying, because we can't factorize the top and the bottom. Sorry, the two numerators are pure. We can't factorize them. So essentially it's asking us to just perform the multiplication to turn 2 fractions into 1. We can do that. So the bottom is pretty easy. 2 times 5, 10. The top a little bit harder, so we can draw a box down the side to be sure. 3x plus 1 and x minus 2. So we've got 3x squared, x minus 6x and minus 2. So let's just write that along the top. 3x squared. And these are common terms, the minus 6x plus x, so we end up with minus 5x and minus 2. Question. You know, we talked about this earlier. What is simplified? And actually I'm going to argue with myself here and say technically simplified is factorized. It really is contextual, I suppose, sometimes. Depends what you're after. But that is technically simplified to a higher degree. So I'd probably go with that one. Do you want to check the equivalent GCSE from Romania? Where is the equivalent GCSE from Romania? Do you mean the IGCSE? I can tell you that the mathematicians in Romania are, I don't know what they're doing with maths over there, but there's some clever mathematicians in Romania. So maybe the GCSE is harder. But maybe I'll look into it another day. Let's finish at the bottom of this page with this one. Hopefully you notice that the top here is the difference of 2 squares. And who's going to make a bet that one of these brackets is going to cancel with the one on the bottom, right? So let's do the easier quadratic first, and it might make our life easier when we factorize the bottom one. So square root of 4x squared is 2x. So that goes in the first two. Square root of 25 is 5 plus minus. Okay, now when it comes to factorizing this bottom quadratic, one of them is going to be one of the ones on top, I'm sure of it. And this is a really cruel question. So it gives us a clue though, because if we say that both of those brackets have a 2x, then to make 8x squared, it must be 4x on the other side. So there's that. And 5 has only got like 1 and 5. It's the only thing possible to get to that. So it depends on which one we put it in. So we're looking at two brackets. This is me reverse engineering stuff, right? There's a proper way of doing it, but I'm just see if it's quicker by reverse engineering. Okay. So if it's 1 and 5, it's either going to be 1 and 5 or 5 and 1. And we can sort of work through some of those. It's either going to be both negative or both positive. It's probably quicker to do the method straight up by this point. So 5, that's 10x plus 4. It's not positive both. It's not that way around. This one's 20 plus 2. This one is pretty good. This one, if it was both positive, gives us the 8x squared plus 22x plus 5. That's what it gives us. But we're looking for a negative 22. So in fact, I think we want them both negative, otherwise we won't get a positive 5. Let's see if that works. 8x squared. Sorry, just stuck it. Minus 2x, minus 20, yeah, minus 22x, and then plus 5. Yeah, that works. So let's put that in. 2x minus 5, and we kind of did it based on the assumption that it was going to. I think it was just as quick doing it as if you didn't realize. Just use this method here. And I'll show you the AC method for quadratics just in case you've never seen it. A is 8 and C is 5. So let me show you what I mean. Ax squared plus bx plus c. So the a times the c here would be 40. And 40 has its own factors, and there's a number. We're looking for two that give us 22, and as you can see, it's probably this. And then we rewrite the quadratic on the bottom in terms of 2 and 20. So it's a kind of a guess sometimes which one goes with which. But we want to get to negative 22 to find an equivalent. The 5. I think that means that the 2 has to go with the 8 and the 20x has to go with the 5. As you can appreciate, 20 and 5 have got the common factor 5. 2 and 8 have got common factor 2. If we had it the other way around, nothing would happen. Now we're going to factorize each side. 2x is coming out of here, which leaves us with 4x minus 1. And what's coming out of here? I've got to take out minus 5. That's all we can do. So that would leave us with 4x minus 1. And thankfully, we have a common factor bracket here and here. And that's going to, we're just going to factorize that overall thing now, which is going to lead to 4x minus 1 is common in both terms, and that's have 2x minus 5. So we get to the same result by doing the AC method. And at least the method is structured so like, oh, if I work through it, I'm going to get there. I'm not guessing. I'm not being spontaneous and trying to be too clever. So methods probably beat tricks in the exam. Anyway, where are we at? Cancelling out. And our final simplification, 2x plus 5 over 4x minus 1. And we've simplified it. Yippee! yeah, good place to leave it. Good to see y'all, and this is to be continued. We've been going at this way longer than I thought. Sorry about the time difference, but I'll set up another session pretty soon this week, and we'll finish this. But so far, so good. It does give you, however, extra time to work your way through these questions. By the time we get to going through the answers, and they're all on my Patreon. So I think this is it. Patreon.com/T formula. There's tons of stuff there to download. Consider becoming a member, but it's up to you. You can ask questions on there, anything. It's a whole community thing. And see you in the next one.